first one, I think that's like 1.5 across. Anyone else get that? Maybe 1.6. I'm calling it 1.5. So I'm measuring in centimeters. That's what I'd recommend here. .8 maybe wide or deep. And a height. 2.2. Anyone getting something similar on that first one? You are? Okay. All right. And next one. I'll call that 1.9-ish. We don't have to be all exactly the same, but hopefully we're in the ballpark. So I'll write my dimensions up there in a moment. All right, so I'm going to whip out a spreadsheet to help me with my calculations here. And my preferred spreadsheet is Google Sheets. And I'm going to leave some time today so we can go to the lab and mess with spreadsheets today, because we're going to do a couple of spreadsheet exercises. Let's see, I don't have a new folder for Math 105. And in there, I want a new spreadsheet. Okay, so what do we have? We've got small thing, the medium thing, and the large thing. And those things have dollar amounts of $750, $904, and $1,178. And then ultimately, I want to know the volume, but we're getting there by doing length, width, and heights. Okay, so the length of the small one, I was thinking it was about 1.5 centimeters. And its width, I was thinking about 0.8. And height was about 2.2. Anybody get anything drastically different than me? Or you guys, we in the ballpark? Ballpark, okay. And we don't have to be exact, just somewhere in there. But if somebody thought it was 3.2 or 1.5 wide, then we might have a problem. All right, next one I thought was about 1.9 centimeters wide and long, 0.9, not quite a whole centimeter, but close. You could call it 1 if you want. I think last time I measured, I thought it was pretty close to 1. 2.5 tall, I was thinking. Anybody wants to argue with me, that's always fun. And then 2.4 by 1.2 by 3.2. And then the bag is kind of like a box. If you multiply length, width, and height, you get its volume, right? So I can just tell the computer to do that for me. Volume. Anybody know how you type an equation to do a calculation in a spreadsheet? Yeah, you type equals first. So if you just type a number, like if I just typed 2 times 3, it's going to say, hey, that's 2 times 3. But if I type equals 2 times 3, then it says, oh, you wanted the answer 6. So the equal says, give me an answer. Now, instead of retyping those numbers, all I do is point to them and click on them. And it says, you want the number in that box times the number in that box times the number in that box. And I'll try to do spreadsheets with you all at least once a week to help you get used to it. So it says it's that first one is about 2.64. Now, one thing that's missing from my spreadsheet, this column is pretty clear, right? I've labeled it dollar. Maybe dollars would be better. But if somebody like that wasn't in class today looked back at the length, would they think that was 1.5 what? It doesn't say, yeah, so I should put that here somewhere. So my preference is to up by the length to put like centimeters. Sometimes you'll see people put like parentheses, it's in centimeters. I just want to make a note. So whether I'm writing this on paper or in a spreadsheet, I should label it. I'm going to add that into each of these. And then volume, so if length is in centimeters and width is in centimeters and height is in centimeters, what would the volume be measured in? Cubic centimeters, yeah, or centimeters cubed. You could go either way, yeah. So sometimes somebody might write something like CU, CM for cubic centimeters. Somebody else might write it as centimeters raised to the third power, cubic centimeters. So it depends on where you see something like this. People will write it different ways. But algebraically, if we take something times itself, we've just cubed it. So that's cubic centimeters. All right, here's the cool thing. Check this out. When I double click on this formula, it switches from showing me the number to the actual formula that was in there. And wouldn't you agree that each cell underneath, I wanted to do kind of the same calculation, multiply the three things to the left? So I can just, instead of redoing that whole point click times, if I click on the original formula, notice this little cute blue button here in the bottom right corner of the active cell. If I click that and drag down, it will try to reproduce that formula. And this time, it's grabbing the ones in the right row. Okay, that's an idea called relative cell referencing. So those are the numbers I get. So hopefully when you multiplied your numbers on your calculator, did anybody try that yet? You get a similar number in the ballpark, 2.5, somewhere between 2 and 3. We're cool. This number is going to be somewhere between 4 and 5, maybe 3 point something. This one's probably going to be somewhere between 8 and 10, depending on how you measured. So as long as we're in the ballpark, doesn't matter whether we have the same numbers. So the big question here is, are the changes in volume similar to the changes in dollar amounts? So we're going to check that out. How did we look at the change in dollar amounts in class last time? What did we do for that calculation? What did we play around with most of class Monday? Percentages, yeah, we looked at percent change, right? So we just need to look at the percent change on those volumes, see if they match the percent change on the dollars. So just a reminder, calculating percent change. We have some old amount and some new amount, and usually what we do is we find the difference, right? So that's always going to be, or usually going to be, the new number minus the old number. And then to turn that difference into a percentage, we just divide by the old number, is the usual way you do it. Okay, and we did that for the 750 and the 904. We got a percent change. So let's repeat that for fun. So whip out your calculator. And for the 904 minus 750 over that 750, about what was our percent change? So you guys calculate that or look back at your notes from the other day. I'm going to recalculate it on my spreadsheet. Where's my spreadsheet? It was like 17%. That's what you wrote down? Okay. So I'm going to add a new column, insert column to the left, and I'm going to call the column percent change. And I'm going to put the percent change right here. So one tricky thing in a spreadsheet, when I write things on paper, I can stack a fraction. I can't do that when I'm typing in a little box or on a calculator. So I have to put parentheses in the right spot. And so keep in mind, wouldn't you agree that when I whip out my calculator, I'm going to do this subtraction first, and then I'm going to divide? So I have to use parentheses to tell my calculator or my spreadsheet to do that right. So order of operations is super important here. So I want to go equals, parentheses, take the new number minus the old number. And again, since they're already typed on the screen, I just click. I don't retype any numbers. Close parentheses, divide by the old number. And okay, it was about 20%. Yeah, so it's about 20, 21%, let's call it. So this guy is approximately a 21% increase. All right, so now we're going to do that for the volumes. So let's see, here's my volumes. So my volumes are, let's call that around 4.3 and around 2.6. So we're going to compare that. Uh-oh, where'd my magic pen go? Disappeared. There you are. Oh, where'd you go? Tools, tools. Huh, computer's misbehaving. Uh-oh, they disappeared completely. Sorry, technology's always fun and exciting. There they are, okay. So I can switch color. So what did I say the numbers were again to the nearest 10th? 4.3. Okay, so we're going to take our 4.3 minus 2.6, divide by 2.6, and if they made their graphics accurately, we should get about 20% again. Do we? Get your calculator out. So I'm going to make a new column here called percent change for the volume. And just like before, equals parentheses, new number minus old number divided by old number. Enter. Ooh, that second bag is actually 60% bigger, even though the financial amount is only 20% bigger. So did they distort reality? Yeah, they're trying to make me believe that $904 is a bigger jump visually than it really is. Okay, that's a problem. In statistics, there's a thing called a lie factor. And the lie factor is comparing how much bigger one change is than another. So to calculate a lie factor, if you look this up online, it's not in our book, unfortunately. It's the percent change in the graphic divided by the percent change in the actual numbers. So for us, we have approximately a 60% change in the size of the graphic, 60% increase, and we only have a 20% change in the size of the actual dollar amounts. So if you take 20 into 60, what do you get? 3. So the lie factor here is 3. So their change is 3 times greater than it's supposed to be, is basically what that says. In a perfect world, that should always be the same. It should always be 1. Shouldn't be less than 1, shouldn't be greater than 1. But here we have a clear distortion of reality with that graphic. Okay. So what I want you to do next, just to test out that percent change idea, because it's an important calculation we're going to see later in the course, what I'd like you to do is blow this up a little bit more. Find the percent change going from 750 to 1178. Compare that to the percent change going from the 2.6 up to the 9.2. Okay, so I'm going to highlight the ones I want you to change, do a change on. Oh, here's another cool trick on a spreadsheet. You can click and highlight a whole bunch of stuff at once. If you click somewhere, hold shift, and then click somewhere else, it selects everything in between. But if you click somewhere and you want to get something that's disconnected, you hold down control. So after my first click, if I go control click, control click, control click, I can select things that aren't connected. And so then I could do something like change the background color of all of them. Let's see, oh, here's background color. So let's make them yellow. All right, so we need a percent change for these two. We need a percent change to those two. What's your guess? Are they going to be the same percent change? Based on the first one, probably not. Let's see how far off it is. So make those calculations, and then we'll see if I get the same numbers you all. Hopefully we all get about the same thing. And you can use your numbers or my numbers. Either way is okay.
Oops.
First one, I'm getting like 57-ish%. When I look at the volumes, remember parentheses if you're using, depending on the calculator you're using. Whoa, 249%. My goodness. So one nice thing is the computer will calculate those for me. So if I was using rounded versions of these and I whipped out a different calculator, let's see, what are my numbers again? 2.6. I might type into like my Google calculator 9.2 minus 6 points. I forgot 6.8, 6.4. What was it? 2.6. Whoa. So I get the actual change is 6.6, and so then I want to divide that by the 2.6, and I get about 250% roughly. So depending on which numbers you use, our number is going to be a little off. Do we have a distortion of reality again? Yeah, it should be about a 60% increase. We're getting a 250% increase in the actual size. So that third graphic is even more distorted than the difference between the first and the second one. Okay, so somebody made a pretty picture here, but they either intentionally or unintentionally lied to me visually. Okay, so there is a lie there. To find the lie factor here, you would ask, how many times does 60% go into 250%? Right, we would find that's around 4, I think. Double check that, someone. It's about 4, yeah. So there's the distortion is the image is 4 times bigger than it should be. Has an increase of 4 times more than it should have, which is a problem. So is 4 times, if somebody says, I'm going to give you this much, but somehow they make you believe it's 4 times more than you're actually getting, would you be upset later when you figure that out? Probably, you know, if it's money or candy or something I like, yeah, I think I'll be upset about that. So that is a problem. Are there worse lie factors out there in graphics people make? Yeah, I've seen lots of factors that had like a 20 times lie. And often it's not intentional. Somebody just thought they were making a really pretty picture of the data, but they accidentally visually misled us. Other times it is totally on purpose. They're trying to pull you in a certain direction, and they do so with the pictures. And we are all, like when I look at this, I'm looking at the pictures before I read any of the words, and that's stuck in my head, right? So even though I'm going to read certain words, the pictures may override the words I read subconsciously. That's dangerous. Okay, let's see. So I put this in a spreadsheet. Just like when you write notes on paper so they make sense to you later, you should label everything. So I tried to label stuff. I think I did a pretty good job here. I should give this a better title. Sense change, graphics from bank. These days, you're not limited. You can make your title of your file as long as you want. I think that's more than long enough. Enter to fix it. The cool thing about doing it in Google Sheets, it's there right now, and I can share it with anybody easily, or I can go home and it's in the same place, which is kind of nice. As far as sharing stuff, if you did this and you wanted to share it with me, you would just click the share button, and then you would just type my email address, and then I would get a copy of it. Anybody want a copy of this that has a Google address? Nobody really cares. Nobody wants it that bad. Oh, fine. Okay.
Yes, I want it.
Oh, Fen wants it. Okay, so somewhere I have Fen's address. Let me see. Is it still in my clipboard? Share. Nope, that's not Fen's address. Let's see. I had it somewhere in an email. Where did I put that email? It's over here. Cancel. Let's move you to another screen for some privacy for a second. Zoom, copy, spreadsheet, share. All right, little note, enjoy, and send. Yes. Okay. So what'll happen, Fen, is if you go to your Google account or Chrome and you bring up Drive from the menu, your Drive may be in a different spot. Shared with me, you'll see that that file %change for graphics from the bank will be in here in your shared section.
Okay,
and then you can choose to add it to your drive or just look at it anytime you want. All right, that was fun and exciting. I can see you guys can hardly contain yourselves. I'm gonna do another spreadsheet example for you, and then we're going to go to an amusement park and do some work. Okay, so back to our course homepage over here. So under the %change thing, I also had a link to a page about lie factors from another website that I thought was pretty good about how to calculate them. You can't help but notice things going on in the election today. And so I'm going to take a look at some current polls on presidential voting, how people intend to vote. So I'm going to if there's a table in a web page, you can usually highlight it and copy it, Control-C. Go over to a spreadsheet. So I could make, let's see, Math 105, new sheet, and I should be able to just paste it in here. Starts blinking in the upper left here eventually once it loads. Come on. Done. Done. There we go. Paste. And 90-something % of the time it'll paste in okay. Here that column's a little narrow, so I can widen it. And so I'm going to go look up the numbers from that poll I referenced here. So right here is the link. Click the link above. Politico. Okay, so here's some numbers. So let's copy those. Another trick on the computer, if you take a window and you drag it to the edge, it fills up half the screen, which is kind of nice. So I can see these side by side and type some stuff in. So they give percentages here. So let's see, Clinton is at currently 43 according to this poll. Trump is at 37. Johnson is at 9%. Steen is at 3, or is it Stein? I haven't been paying attention. It's Stein. Thank you. People that will not vote, 2. People that still want somebody else, about 2. Not sure, 2%. Depends, who knows what, 1. And would not vote. I wonder what the difference between none and would not vote is. Oh, okay. Okay. So this apparently came from NBC News and the Wall Street Journal, and they have a margin of error of about 3 percentage points, which means like that could really be 0 or 6, for example. Now, let's see. Total, what should these add up to? Should add up to 100% if they did it right. So the computer will do that calculation for you. And so to make that happen, oops, let me blow this up. I go to More, and then this cute little button there is a Greek S for sum, add stuff up. So if I just click that and then click sum, it'll say, what do you want to add up? And I'm going to close that, click back in the middle. There we go. In the middle? There we go. And then I can just highlight what I wanted to add. And notice it puts a colon in between, which means go from here to there, everything in between. And then I just hit enter, it says, yep, that adds up to 100. So next thing I want to do, and this is going to be the tricky math part, because I actually want to know, they say they only interviewed 922 people, okay, of likely voters. So I want to know, well, of the 922, how many, what is 43% of 922? So I just want to do that calculation. So yeah, so that's the question. Do we multiply, do we divide? It's going to be one of those. So we know the total down here should be, let's put it under here, 922. What do you think? Yeah, we'll have to make it a percentage, right? So how would I make 43 into a percentage? Okay. Okay, how do I tell the computer to move the decimal over? You do too? We wrote it on the board last class, who knows? Madeline? How do we change 43 into 0.43 on the computer, on a calculator? Almost, try it again. Divide by 100. Yeah, if you divide by 100, that'll shift the decimal place. Yeah, so we just tell the computer, take this number here and divide it by 100. Okay, so that's how I use 43% in a calculation. Okay, now what do I do with that number next? Times, yeah, the 922, yeah. So then I just go times 922. And here's the cool thing about a spreadsheet. All I have to do is set up that calculation once, then I click back on it, and then drag it down. Okay, now I have fractional people, which is kind of a problem, right? What's 0.46 of a person? 46% of them is going for Clinton, and the other 54% is doing something else. I don't know. So we should round these, and I can tell it to round. They're already highlighted by using one of these buttons. Increase decimals, no. Decrease decimals. So if I hit that once, twice, now I have whole numbers of people. What should those guys add up to? 922. Now check this out. I already told this box over here to add up the numbers above. So I have two options. I could go here, hit that sum button, hit sum, and then highlight the numbers above. 922, it worked. Or, since these two formulas are essentially the same, they just say add the stuff above, I could have just filled this one over like that, and it's going to do the same thing. So so as often as possible, I'm going to show you these spreadsheet tricks, because I think when you leave college, you'll be much more an advantage compared to somebody who's competing for a job with you if you're more spreadsheet competent than they are. Right? Question? Yeah, so to get rid of the decimal points, when it did the calculation, so let's repeat it over here, equals this, divide by 100 times 922. I hit enter, it's a decimal answer. So to tell it to round, these buttons up here can give you more or less decimal places. So if you said this was a measurement and you need it to be more exact, you could increase the decimals or decrease the decimals until you get what you want. Okay? There's also another way to do it, but I'll show that this is the easy way. So there's a harder way. Who cares? Why would you know? Anyway. So again, this is something we'll go to the lab in a little bit and play with a spreadsheet. So I want to see if you guys can reproduce either this sheet or the percent change sheet. Okay, and the more practice you get, the better. So hopefully every week I'll find at least one spreadsheet exercise for you. Okay, we should give this one a name. How about presidential voting poll? If I was going to share this with somebody else, they'd want to know where I got my information. In a lot of classes, you have to cite your sources. So I would just simply go to that other page. Where's that other page? Are we okay, Micaiah? You all right? Okay. And then what I would do is just go to this page and just click and copy that whole address and then paste it in to my sheet here and do something like source, oops, paste it in so that somebody knows where I got my numbers, that I'm not making stuff up. All right, that was fun and exciting. Yes, we will. You could do the exact same thing. Yeah, so what I'd recommend we do, and so maybe in about 20 minutes we'll break, or 25 minutes we'll break over to the lab. You could go over to our course homepage, over here, and you could either type in the numbers from our work with the graphical change, or you could copy and paste this in and try to do those calculations. This is the easier one, I think, so that might be the better place to start. All right, reminder about the course website. Every week we have a new topic. So hopefully you've already read through the do this first and the course information. I think everybody had a bio for me to read. I'll look at those some more tonight and you'll get a free 5 points there. And then otherwise, when you jump into the course, sometimes I'll have some extra stuff that's related to what we do in class. And sometimes I remember to put a little note that that's just an in-class activity. It's not worth a grade. It's just something we need to do to learn this stuff. The book will usually be the first link. Then there'll be some links to videos, the things we're supposed to learn, a summary of what's in the book, basically. There's a questions forum here if you want to ask a question about something, and the problems are linked to it. So if I go into the problems, you should see a link under each one, post a question to the forum. So that goes to that forum. When you do it, it will actually copy the problem into the question, and you can say, hey, I tried blah, 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 it didn't work, can somebody point me in the right direction? And if somebody in the class comes up with help for you before I do, then I consider that like for extra credit at the end of the quarter. And then if you find any typos in the book, there's also some extra credit for that too. All right, so let's say I didn't really want to do that. So backing up here. Okay, so you have exercises. You can do those as many times as you want till you get them right. Skills quiz. Don't do that until like Friday after class, maybe would be the safest time to do that. And then there's a writing assignment. This second part's invisible to you until tomorrow, I think. Yeah, because you got to do the first part first. And then Thursday, the second part will be available, and you can jump in and try that one. And it's very exciting. You're going to love it. Okay, so what do I need? Whiteboard. Okay, we're going to do something with rates of change. So rate of change people are most familiar with would be something like miles per hour. On the highway, what's the speed around here? Is it, did they bump it up to 70 recently? 65, 70 now? What's that? Athena here, it's 55, right? Yeah. So sometimes we'll see things like 70 miles per hour. The Athena highway had 11, 55 miles per hour. Driving by a school, you're supposed to do like 20 miles per hour. On a good day, I can ride my bike for a while for an average of 15 miles per hour. Right, so that's a common rate. Per from last week, anybody remember what per means?
Divide.
Yeah, divide, part of a whole. So what they're really saying here, another way to write this, would be that this is actually 70 miles divided by, well, I guess I'd have to divide by 1, right? To keep the 70 by 1 hour. So that's another way to look at this. When I have a rate whose denominator isn't written, meaning it's 1, that's called a unit rate. Okay, so that's a unit rate. So everything I wrote on the board right now, since there isn't a visible denominator, they're unit rates. Okay. Other times you'll get rates like, I went on a bike ride the other day, I went 36 miles, and it took me 125 minutes. That is not a unit rate because the denominator isn't 1. Okay, so let's make that into a unit rate. First problem, I usually don't give speeds in miles per minute. I give them in miles per hour, right? So there's another kind of rate we can use to do a conversion. They're just called conversion fractions. And all you have to know are 2 measurements that are equal. So give me something that's related to minutes. Seconds or hours, yeah. And so then I just need to know, well, how many minutes are in an hour? 60 minutes is 1 hour. To do a conversion rate, when you have an initial rate, it's a fraction you're going to multiply by. Since minutes we want to go away, we put it in the top of the conversion rate. And in the bottom is the other unit I would prefer. Okay. Miles per hour, I do want hours in the denominator. I need to cancel minutes, so when I multiply, the minutes need to be in an opposite location to cancel. And then I know that there are 60 minutes in 1 hour. And the whole point of a conversion fraction is it reminds you whether you should multiply or divide by that number. So that's the point. Because every once in a while, don't you have a bad day and you're like, oh, do I multiply or divide by that to change it? Some days I'm good at that, some days I'm not. Conversion fraction sets me straight if I'm not sure. So doing this calculation will give me a unit rate. So whip out your calculators. Let's do this calculation. So what it says to me is, let's see, what does this bar right here mean? It means divide, yeah. So from the 36, I have to divide by 125, and I have to multiply by 60. Does the order matter? Let's find out. Whip out your calculator. I'm going to use Google. So 36 divided by 125, excuse me, times 60. You could do it in stages or all at once. First time through, I get 17.28. Anyone else? You got that? Okay, I'm just going to do it in a different order for fun. What if I did 36 times 60 and then divided by 125? Oh, turns out the order didn't matter. Kind of cool. And looking back at that, the way I wrote it on paper, I really don't need parentheses here. So if parentheses aren't involved, you can usually kind of do it in any order you want. Okay. So this turns out to be exactly, so I can use an equal sign, 17.28 miles per hour, which I could also write as 17.28 miles divided by 1 hour, which uses way more ink, but it means the same thing. So remember, the blue thing above is not a unit rate. Unit means one thing. The red version is a unit rate. And so sometimes we like unit rates, sometimes we write the whole fraction. Okay, so we looked at conversions a little bit. That's a popular rate we can use to change from one unit to another. The idea of a rate versus a unit rate. So here's the next thing. Carnival was in town recently, and although I used to like crazy spinny rides, I don't anymore. But I do still like the Ferris wheel. I like going around the Ferris wheel and looking around town from the top. So I went on the Ferris wheel. So here's the little box there. Oops. And here's me sitting in the box, waving hi. And the Ferris wheel is going round and round. And as I was going around, I can't help but think mathy thoughts. And so I was thinking, how fast am I moving? Can I figure that out? So what do you think I needed to do to try and figure that out?
We can try count how many circles that you, how many circles does it turn in an hour or in certain minutes? Yeah.
So I whip out my phone, I get the little timer, and I start tracking how long it takes to go by. So my young daughter thought this was crazy, but I had fun. So I would just, use this, how stopwatch you can do intermediate times. So I kept doing that. I kept hitting the button for an intermediate time. And so it was a different time each time. Like sometimes it took 19 seconds, sometimes 17, sometimes 16, sometimes 20, because the guy was playing with the lever, I guess. So on average, I think one revolution took about, I'm going to round to 17 seconds. Okay, so I know how long it took to go around. to get from here all the way back to there. Next thing I need to do is figure out what that distance is. Now, I didn't have an extra long measuring tape on me to wrap it around this thing and measure it, so I had to find another way to do it. Anybody have a thought about what I might have done to measure how far around this sucker is? Yeah, I walked outside onto the sidewalk nearby, and I paced off with my feet how many feet it was. And in most walking shoes, my foot is pretty darn close to 12 inches. Okay. So it was rough, but I got the right idea. And then I looked down at the sidewalk, and I noticed the sidewalk was made of bricks, and each brick was 8-inch wide. So I also counted the bricks to see if I got it right. So I was checking my work. And so I also found that one revolution, one diameter was 50 feet, pretty close, rounding a little bit there. It was about 50 feet. So the distance from this side straight across wherever the middle is to the other side. So that's a diameter. So then I got to remember, okay, on a circle, how do I take a diameter and turn it into the distance around? What's the distance around called on a circle? The circumference? Yeah, circumference, yeah. And I need pi also. And so I can write here. So circumference is equal to pi times the diameter. Some people remember the formula circumference is equal to 2 pi times the radius. And that kind of makes sense to me because you need 2 radiuses to get a diameter, right? So 2 versions of the same formula. Okay. So putting that all together, or at least partially together, I think that one revolution of that Ferris wheel was pi times 50 feet. Now, when I don't have a calculator handy, I call pi 3. So that means it was about 150 feet around. 3 times 50, right? What do we usually use for pi? We usually use about 3.14, yeah. Some calculators hold more decimals of it. Did you know there's a pi club you can get in? And you have to know more than 100 digits, I think, to get in it. So if anyone's bored, needs to be in a new club, get some more social interaction, the Pi Club is available for all. Sounds exciting, huh? All right, so let's see. Where's my Google calculator? There it is. Is there? Oh, there's even a pi button on this. Clear. What is pi? Google says pi is 3.14159265359. And pi is a crazy number. It keeps going without repeating a pattern that's predictable. We can keep calculating those values through some crazy math, but it's not like, for example, if I type 1 divided by 7, you see a pattern going on there?
Mm-hmm.
Yeah, 142857, 142857. If we sort more, it just goes 142857 forever and ever and ever. Right? Another one most people are familiar with, 1/3, 3333. It repeats a pattern. Or let's see. Oh, there's a cute one. 5/11. Ooh, I forgot to hit divide. 5/11. 45454545. I think you get that pattern, right? But pi doesn't have a repeating pattern like that. It just keeps going and going and going, which makes it kind of trouble. But for most human beings, 3.14 is more than good enough. Okay. So one thing I'm pointing out, the differences in pi. It's possible for the same problem, we can each get different answers. Because I use the calculator button on Google, and you use the calculator button on your phone, and you use 3.14, and you didn't have your calculators, you just used 3. Right? So I'm just making stuff up. But can you see how it's possible we can get different answers for the same problem? And as long as we're in the ballpark. So 3.14 times 50, 157 feet. Let's go with that number. Okay, so this is approximately wavy equals sign 157 feet. Do I have enough information to figure out my speed? Right, speed is just distance over time. Do I have my distance? Yeah, do I have my time? Yeah, so I can write down my speed. So I think my speed on the Ferris wheel, if me and my phone were correct and my feet were correct, is about 157 feet divided by 17 seconds. Does anybody have an intuitive feel for how fast that is? Who here is used to measuring in feet per second? Not me. Like I know some baseball players are, because sometimes they measure baseball speeds in feet per second, but usually it's in miles per hour. Right? I'm used to miles per hour. Anybody know about how fast you walk miles per hour? 2, 3, 4, maybe if you walk really fast, 5 miles per hour, right? But most of us probably walk like 3 or 4 miles per hour, I bet. Yeah, so I would like to know, is that like as fast as I walk? Like, think about being on a Ferris wheel. Could you, on a good day, step off without getting injured too bad? Is it about how fast you walk, or would you jump off and that would be like a running speed? Would it be like jumping out of a slow-moving car? Any guesses? Can't remember being on a Ferris wheel. It's been a while. Okay. I'm thinking if I jumped off and I had a clear platform, nobody in my way, no rails, I'd be okay if I had a little running room. It's a little faster than I walk is my guess from being on it. So let's do it. So what do we have to do? We have to convert seconds to and minutes and then hours, and we have to convert feet to miles. Anybody remember how many feet are in a mile? Ooh, nice job. Yeah, let's use a different color. There are 5,280 feet in 1 mile. And then we could use the fact that there's 60 seconds in a minute and 60 minutes in an hour. So using that idea of conversion fractions or multiplying and dividing in some special order, see if you can give me a new answer here in miles per hour. So everybody try a calculation. I'd recommend writing some stuff on paper as well as using your calculator. And then we will compare notes momentarily. And there's multiple ways to get the answer. We should all be in the ballpark, hopefully. Oh, wrong button. $5,280 feet in 1 mile. Okay. Yeah, so you can do it in a different order, but I think I have the solution sketched out here if you want to take a look at any time. So I didn't do the calculation one at a time. I just started thinking, all right, first, let's use this fact up there. And so I wanted feet to be in the bottom, so miles had to be in the top. And then I put the numbers in the right spot. Now, some of you might have just looked at that and just knew, I just need to multiply by or divide by 5,280. But if there's ever a doubt in your mind, do I multiply by that number or divide by that number? That's where the conversion fraction helps, okay? And then I just thought the same thing. Seconds has got to go, which means it needs to be in the top. That changed me to minutes. Minutes needs to go, so it has to be in the opposite position. So this tells me that to do the conversion, I should divide by 5,280, multiply by 60 because it's in the top, multiply by 60 because it's in the top, starting with that fraction. So I'm going to see what I get when I do that. So I'm going to use my Google calculator because it's convenient. So I started off with 157, divide that by 17. Then my conversion fraction said I should divide by 5,280, then multiply. Now some calculators let you continue without hitting equals. Sometimes you have to hit equals and then multiply. We all need to learn how to use the calculators we have in our hands. If you ever need help, let me know. Times 60 again. Google says I was going about 6.3 miles per hour. So hopefully everyone got something in the 6-ish ballpark, which is a little faster than I walk. I run faster than that on a slow day. So yeah, if there were no obstacles, I could have stepped off this thing without getting hurt, but there were obstacles, so it's a good thing I didn't step off. So I'm going to call it about 6.3 according to the way I use the numbers. Oops, that's a highlighter. It is 6.3. Places will get different answers depend on if you rounded intermediate steps. So a place I might have rounded intermediately is I might have taken the 157 over 17, done that calculation and wrote the answer on paper. So let's see what happens if I do it that way instead. So clear 157 divided by 17. That gives me, and maybe I decided to call it 9.2, ignoring those decimals over there because that's where I might round it. So then I proceed with the 9.2. Oops, wrong numbers. 5,280. So if you do it in stages and round at each stage, you're going to introduce error. So how much error might I introduce by doing it this way? So then so now I take 9.2, divide by 5,280. Whoa, that's a little number. Shall I just call that 0.0? If so, I'm not moving. So that's a problem. So now I got to say, oh, how many decimals should I keep? What do you think? You're going to write this on paper? How many would you write down? Would you call it 0.0017? Would you write all of them down? Let's make believe we're having a surprise quiz right now. What are you going to write on paper? Somebody help me. You always go with the first four. That's what I was thinking. Yeah, I would go with the 0.0017. Yeah, so 0.0017, and then I was supposed to multiply that by 60. Decide I'm going to keep all of those, multiply that by 60. And I am in the ballpark, 6.12 instead of 6.2. I did a lot of rounding, and I'm still not too far off. I have had bad days where I rounded too many times in between, and I was way off. Right? But usually you're going to be in the ballpark. You're going to get an answer below 10 instead of above 10. Right? So we're close enough. That's not too bad. So if somebody wrote that as the answer on their test, and I saw the work, I'd be like, oh yeah, that makes sense. Okay. One thing I like to do is whenever possible, use my calculator to my advantage. Do I need to write down all those intermediate steps? Answer is no, I really don't need to round and say that's 0.0017 and then keep repeating that. I can just keep working on my calculator using values that are already there. What's one problem of just doing that all in the calculator like that? Answer, there's no record of it. Right? You look at your calculator, there's a new problem, whatever you did next. So that's another reason why, more than using a calculator these days, I like to use a spreadsheet, because the spreadsheet records all of that information for me. Every calculation I did is hiding right in there, which is kind of nice. So I would say, because most of the time I'm doing math, I happen to have a computer nearby, because I'm in class or a lab or my office, I'm doing my math on a spreadsheet. I don't even touch my old calculators are collecting dust somewhere. I never touch them anymore. I'll use my phone calculator sometimes in a pinch, but most often I'm near a computer, so I'll use a spreadsheet. So I'm going to try to get you guys to use them as much as possible. All right, I think we got time for one more problem, and then we can go play on the computers for a few minutes. Today's Wednesday. We have another class Friday. We do. I said we have another class Friday. Sorry, I was mumbling there. I was mumbling. Yeah, let's do one more. So next I'm going to do a physical problem that's not a speed. The science department is putting in a beehive, and they wanted to have stuff the bees like nearby, so they decided they would put in raised beds to grow bee food plants. So I was helping them with that. So we had to figure out, okay, how big should the beds be? Where are we going to get the soil? And then do we go to the gravel yard and get topsoil, or do we go to some place like Home Depot or Weimar and buy bags of topsoil? What do you think was probably cheaper? Probably the gravel yard, because you can buy a whole bunch. You wouldn't have to pay somebody to bag it. But maybe the bag stuff's more convenient because you got to truck the stuff somehow over there. So I'm going to look at the gravel yard next time. Let's look at the topsoil. So I went to Home Depot, and they had a kind of topsoil. Can't remember the brand name. Topsoil. And that topsoil was $2.47 per bag. Is that a rate or just a price? Yeah, because it's per bag, right? Is it a unit rate or just a regular rate? A unit rate because it's like one bag, right? Unit means one thing. Yeah, so that's actually a unit rate. So that was the topsoil. And then they had some raised bed material. Raised beds. And the raised beds were 4 feet by 8 feet by 10.5 inches. And they decided they wanted 4 of these raised beds. So rough sketch of a raised bed would look, what, something like that, right? It's 4 feet by 8 feet by 10.5 inches tall. Oh, the beds, by the way, they cost $84.32 each. $84.32 each. Because ultimately, we're going to figure out how much this stuff costs to put together. So is there any other information I'm going to need to try and figure out how to price this job? Because someone's going to need to write me a check from the college, because I'd rather not pay with my own money, right? It's a college project. It's going to be for the biology department to study bees. What do you think? What other information might we need? Yeah, dude. I mean, yeah. So how many bags of topsoil are you going to buy? So this is your project now. You're going to go to Home Depot. I'm going to give you a check. I need to know how much the check should be so you could buy the raised beds and all the topsoil. What's that? So I'm going to fill these beds with soil. 1 bag per bed should do it, you think? How big's a bag, right? Yeah, is it a big bag, little bag? How big? How little? Okay, so I did research that. So they claim that a bag is 1 cubic foot of soil. So if you made a box that was 1 foot by 1 foot by 1 foot, that bag would fill it perfectly, is their claim. Took me a while to figure that one out. Actually, no, it was the next part that took a while to figure out. Okay, so cubic feet. So how many of those bags will fit in there? I have to figure that out. Okay. Other question, my other option besides buying those bags was getting soil from the gravel place, like Pioneer Ready Mix. Maybe they have topsoil. Near Mission. Ooh, I still have to calculate how much these guys hold. I know how big they are, but I don't know how much they hold yet. And then how am I going to get it here? A truck, right? I got to pay for the gas, right? Okay. I used to have a little Toyota pickup, one of those little bitty Toyota pickups. Okay. How many bags do you think it can hold? Like, suppose I need 100 bags. Do you think my little Toyota could handle 100 bags? Yeah, probably not in one trip. So how heavy is 1 cubic foot of soil? Do I need to know that? Yeah. So it turns out a friend of mine was working on this with me, and she drove her little Isuzu uh, SUV. You know those little tiny Isuzu SUVs? They barely qualify as an SUV. Uh, how many bags do you think she could hold in there? Maybe 10 before her shocks really start to strain. Okay. So I had to find out how much these weigh, and I did some research, and a lot of people had the same question because I had to go pick it up. And the answer, I'm pretty sure on one of the help lists, was that these bags weigh 50 pounds each. Okay. What's that? Yeah, well, I'd have to drive to Home Depot to see, or I have to call somebody and ask them, right? So this, I went to Home Depot's website, and eventually I found on their website it was about 50 pounds. So like I'm thinking, I've done a lot of cement work in my time, and I know a typical bag of cement is usually like 80 pounds. It's pretty darn heavy. This is heavy, but not too bad. It's like a small child. Okay, so our task now is to figure out how many of these bags I need, and then we'll check out like how are we going to deliver them, right? That's the other problem we have to deal with next. But how many do we need first? So what
28.
information? What's that?
Is that 28?
You think we need 28 bags?
Mm-hmm.
Okay, we have a guess of 28. So somebody else, do a calculation, see what you get. Okay, Fen believes it's 28 bags. Oh, sorry, she's talking in my ear. I should have put her on the other speaker so you guys can hear her. It's kind of weird. Let me fix that. Yeah, a minute ago, you were talking and she was talking at the same time, and I was really trying to focus on both of you. So let's fix the speaker situation. Somehow I thought it'd be less distracting, but it's like that one. Save. Okay, so she's going to come out on the classroom speaker now. Can you say something to test it, please?
Yes, sure.
Good job. Okay, we can hear you. All right, so let's see. I'm going to do a calculation. Well, the area is easy. 4 times 8, 32 square feet across the top. And then what do I do with that number? It's 4 by 8, 32, isn't it? On a good day? Yeah, okay, sometimes I forget those little things. What do I do with the 10.5 inches? Multiply by 10.5?
Convert the inches to feet first.
Yeah, this has got to be feet, yeah, because then we get feet squared times inches, which is like, what's that? Yeah, so we got to convert that to feet. So we got to divide that sucker by 12, because there's 12 inches in a foot. All right, so one bed, if I check with Google, is 4 times 8, 32, good day, times 10.5 divided by 12. So 28 cubic feet, okay? And each bag is 1 cubic foot. Hey, cool. They designed this very well. I need 28 bags, just like Fen said. For one of them, how many raised beds am I doing? 4 of them, okay. So then I multiply that by 4, so I need 112 bags. My Isuzu pickup cannot handle 112 bags. Okay, so yeah, times 50. Okay, so that's multiple tons of soil that we need, and somebody's got to take it on and off the truck. So I'm starting to think I want to call Pendleton Ready Mix and see if they will deliver some topsoil to me. We'll look at that problem next time and compare the costs. So other thing, I have a friend who's got a bigger truck. He's got a farm. He's got a nice flatbed pickup, dual wheels in the back. He could probably hold a ton, maybe. I'll have to check with him. And so, yeah, so we have some answers here. Okay, so we're getting better. And then we can also figure out the cost now. We know we need, what was it, 112 of them? And we know they're what? Are they 247? Is that what I said? So if we back up here, 112 times 247. So just for the bags, I need $276.64. Plus I need 4 beds. Those are 84 something each. Okay. So here I'm wishing I had my spreadsheet out and ready to go because I could see it all at once, right? Otherwise, like you guys, I'm writing all of this on paper. So new page, and then we start writing stuff down. Okay, I'm gonna pause on this problem right here. We're gonna pick it up tomorrow. Right now, what I'd like to do is just, we've got about 15, 20 minutes left of class. So Fen, you're on a computer right now.
Mhm.
You guys, I want you to go into the lab, log into a computer, open up My Open Math, and take a look at trying either your own version of a spreadsheet for the presidential election data,